So we're starting the lesson on 6.6, which is the law of cosines. We're going to start by looking at the equation, and if you're interested in the proof, which I always am, it's actually on page 532 in the book. So here it is, and let's again draw our triangle and make sure we remember the convention of how we label the sides and angles. So if I have angles ABC, then sides ABC, each corresponding letter is opposite the angle with the corresponding letter. So B is opposite B and C is opposite C. So the lowercase letters are sides, so that's a side, a side, a side, 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 angle. So there's only one angle used in the law of cosines. So notice that angle A is inside the cosine, and side A is opposite, and side A is on the opposite side of the equation. And the B and C and the B and C in here are the other sides that are not opposite angle A. You could rewrite the equation 3 different ways with B in the cosine and C in the cosine, but I think it's easier just to label your triangle so that angle A is the one that you either know or are trying to find, and then side A is opposite side of the equation. All right, so we're going to find the angles of the triangle when we're given 3 sides. So these are sides, so there's not really anything, we don't need to draw it because it's clearly just 3 sides. So I can plug everything in here. Since I literally have 3 sides, it does not matter which one I put where. So let's go for angle A. That's my cat, since it can match this equation. So A is 5, so 5 squared equals B squared plus C squared minus 2 times B times C times cosine of A. So now we need to solve this. You cannot combine all of these number values together because these are factors with cosine and these are terms. So these are kind of attached to the cosine. So we can subtract 8 squared and 12 squared. So we have 5 squared minus 8 squared minus 12 squared equals negative 2 times 8 times 12 cosine of A. And then we can divide by this. So divide by negative 2 times 8 times 12. So that expression is going to equal cosine of A. So I'm going to say this is your answer for that step in your calculator. And then you would do cosine inverse of what you just got there. And what mode do you need to be in? It does matter because you're finding an angle using a trig function. And so let's assume that we're going to be in degree mode. So put it in degree mode. And we type that in. And it turns out that angle A is 17.6 degrees. So we were trying to find all of the angles and we have one of them. So we've got 2 more angles, B and C. And you could use the law of cosines, but the law of cosines has more steps in it than the law of sines. So now I would use the law of sines because we have enough information to do that and it's easier. So if I set up sine of angle A divided by side A, and I'm going to randomly decide that I'm finding angle C next, it doesn't actually matter, divided by 12. And we've done these before, so I'm going to assume that you can do that pretty easily. So a couple of steps, solve, and you find that angle C is 46.5 degrees. So that's angle C. And then we're missing angle B, and you could use law of cosines or law of sines, which is easier, or just subtract from 180. So it would be 180 minus A minus C, which we know, and that works out to be 115.9 degrees, and we did it. we have another triangle, and we've got, there's my cat again. We have different information. So we have an angle and two sides. And notice the angle that we have does not have its corresponding opposite side, something that's given. So angle A is going to be here, and the missing side is going to be the opposite of the equation. So a squared, that's what we don't know, is equal to b squared plus c squared minus 2 times b times c times cosine of angle A, which in this case we do know. Okay, so now we're already in degree mode because we just did a problem. And this, we can literally type the entire thing as is from left to right into our calculator without stopping, because everything over here is a known value. So we type that in, and we get a squared equals, I didn't actually write the in-between step down because I kept it in my calculator. And then you would take the square root of both sides, and you would find that side A is 13.2. Whoops, sorry, that was from a different. Oh no, it is 13.2. Yes, okay. So we found side A, and the directions are to solve. So we have angle A, and now we have all three sides, so now we're just missing the other two angles. So we could use law of cosines again, but like in the previous problem, law of sines is simpler, so we're going to use law of sines. So if we go for angle B, doesn't actually matter which one you go for next, but I would have sine of B over side B equals sine of A over side A, and then solve that. And at the end, you're going to have to take an inverse sine to find the missing angle, and you will find the angle B is 35.1 degrees. All right, we're almost there. We got one more angle. So angle C, you could use law of cosines or law of sines, or we already have the other two angles, so I'm going to take 180 and subtract angle A and subtract angle B, and angle C is 98.4 degrees. And we've solved it. All right, so this is a definition of compass bearings. So I'm going to do some examples. So for compass bearings, so remember the compass rose, north, south, east, west. You always start with north or south, then the degree, east or west of where you started pointing. So this compass bearing says north 30 degrees east. So if I draw my compass rose, I start by pointing north, and then I tilt my angle 30 degrees toward the east. So that would be here, where this angle is 30 degrees. All right, so this one, I start with my compass pointing north, and I tilt 60 degrees to the west. So that would be like this. So this would be 60 degrees. This one, I'm going to start with my compass facing south, and then I'm going to tilt it 70 degrees toward the west. So like that. So this angle is 70 degrees. And the last one for practice, I'm going to point my compass south, and then I'm going to tilt it 50 degrees toward the east. So toward the east, so like this, where this is 50 degrees. So that's how you find a compass bearing. So now we're going to turn the page, and we're going to do some problems where part of the instructions have compass bearings. So this one's kind of complicated, and we're going to do it. It's going to be great. A pilot sets out from an airport and heads north 20 degrees east, and he's flying at 200 miles per hour. So the plane starts. Sorry about that. So I'm going to draw dotted lines from my compass so that I don't make my diagram have too many solid lines on it. So that's north, and we're going to head 20 degrees toward the east, so that's this way. So 20 degrees, so this is 20, all right? And we fly at a speed of 200 miles per hour, and we do that for 1 hour. So 200 miles per hour times 1 hour equals a distance of 200 miles. So this length of the journey is 200 miles. All right. After an hour, she makes a course correction, so she's turning her direction and heads north 40 degrees east. So I'm going to draw in my dotted north line here, and she's tilting farther to the east. So she's going to be going 40 degrees toward the east. And at half an hour later, she's making emergency landing. So she goes at 200 miles per hour for a half an hour. So that distance would be 100 miles. So this is going to be 100 miles. All right, so we got the diagram. The question is, find the distance between the airport where she started, and I'll say this is L, the landing point. So I'm going to draw that in a different color. Oh, there's my cat again. I don't know why she wants to be part of this today. Oh, that's the same color. So we're going to go from here to here. So this is the distance that we want. So we clearly have a triangle, and we've got 2 of the sides, and we have information about angles, but none of them are the angles inside the triangle. So let's use what we know about geometry to find at least one of the angles inside the triangle. So I'm going to go for this angle. So if I draw in more of a I'm going to extend my vertical line from north. This would be south, but it doesn't actually matter what direction. So this is a straight line. So if this angle is 40, and this is a straight line, the angle all the way to the line again would be 180. So this angle here is 180 minus 40, which is 140. Cat. And then this angle here, that angle right there, these 2 lines are parallel. That compass facing north and this compass facing north are parallel, so these are parallel lines. And these are alternate interior angles, 20 degrees, 20 degrees. So this one is 20 degrees. So this angle here is 140 plus 20. So that angle is 140 plus 20, so 160. So now we've got that angle. So now we're ready to use the law of sines. All right. So we have this side that we don't know, and we have the angle opposite it, which is 160 degrees. So that one's going to be the side that's all by itself on the left-hand side of the law of sines. And then the other 2 sides we know. So one of them squared, so that's 200 squared, plus the other one squared, minus 2 times those same 2 sides, 200 times 100 sine of the angle, which is 160, and it's degrees, so make sure you're still in degree mode. So this, you can literally type into your calculator from left to right, and you'll get d squared equals whatever we get for that. And then take the square root, and you find out that your distance is 96.0, and it's miles. All right, one more part to this, and bearing means compass bearing. Find the compass bearing from the airport to its final landing point. So we're trying to find the compass bearing for this side here. So I'm going to redraw that. Actually, I'm not going to. No, I will. Okay. So we need to know this was the distance to the final destination, the landing point, right? So that's this side that I had orange up there. Okay. And we know that the original path here had an angle between north on the compass and that direction of 20 degrees. That was what we started with right there. And we need to find out this big angle, so maybe we can figure out this angle somehow. So notice that this angle right here, I'll call it theta, is this angle in the triangle that we were working with before. So theta is that angle. So I've got a triangle where I know this angle and those two sides, and I'm missing an angle. So the law of sines will allow me to find theta. So if I do sine of angle A, which I labeled A because that was the airport, over side A, which is opposite the airport, so that's the 100-mile side, equals sine of, we know these two, so we're going to use these two. So sine of 160 over, that was the distance that we found, which was 296. So a couple of steps, you get sine of A equals something, you take the inverse sine, and you find that angle A, which I called theta here, is 6.7 degrees. Okay, so this is 6.7 degrees, so it's not to scale in my diagram. So this angle that I need to find my compass bearing is from north to this direction that the plane was going. So that angle would be 20 plus 6.7 degrees. So that's 26.7 degrees. All right, we're ready to write the compass bearing. So the compass bearing, we start north and we tilt that far to the east. So the compass bearing is north 26.7 degrees east. And this is the last topic in this section, Heron's formula. I assume that was named after a mathematician, but didn't actually look that up. And there's a proof. Oh, I don't think that's the right page. Okay, so if you want to try to find an area of a triangle and you don't have the base and the height, and the sine formula doesn't work because you don't have an angle, you only have sides. So you have side A, side B, side C, and no angles. Turns out this is how you can calculate it. So you substitute the S value in here. So this could be written out with all A's, B's, and C's, but then it would be kind of big. So if you find S first, then you can substitute it in there. So we're just going to do it really quick for this. So if I call this side A, this side B, this side C, I don't really have to draw my triangle. let's set it up. So S is 1/2 the sum of the sides, or the perimeter, if you will. So that would be 315 plus 125 plus 280. And you do that in your calculator. So that works out to be 360. And now we're going to put it into this area formula. So the square root of 360 times 360 minus angle A times 360 minus angle B times 360 minus angle C. And you can literally type this all into your calculator square root first and then type this whole long string into your calculator. And you find that your area, don't forget the square root, is 17,451.6. And there were not units given in this question, but it's an area, so they would be square units.